The following data were collected for the rate of disappearance of nitrogen monoxide in the given reaction. A. What is the rate law? Rate law. Rate is equal to K times the concentration of the first reactant, NO, raised to its order, M, times the concentration of the second reactant, raised to its order, N. So we need to solve for K, M, N. Okay, so the first thing we do is we use the three experiments, the three runs, to set up three equations. So let's analyze run 1. Run 1, what was the rate? The rate was 1.41 times 10 to the negative 3 is equal to the constant K times the concentration of NO is 0.0126 raised to its order, M, and the concentration of O2 is 0.0125 raised to its order, N. So this now is our equation 1. Analyze run 2. The rate was 5.64 times 10 to the negative 2 equal to K times NO was 0.0252 raised to the M. O2 is 0.0125 raised to the N. And this is now our equation 2. Let's do run number 3. The rate was 1.13 times 10 to the negative 1 equal to K, and O was 0.0252 to the M. O2 was 0.0250 raised to the N, and this is our equation 3. Alright, so to solve for K, M, and N, we need to formulate three equations, which we already did, and now we need to have a plan on how to solve for K, M, and N. So what is the plan? Plan? Plan number 1, we divide equation 2 by equation 1, and we should be able to solve for M. Solve for M. Step 2, if we divide equation 3 by equation 2, we should be able to solve for N. Solve for N. And then step number 3 in the plan, we substitute M and N into equation 1. Solve for K. Alright, so that is the plan of attack. So now let's follow the steps. Step 1. Again, step 1 is divide equation 2 by equation 1 so that we can solve for M. So equation 2, 5.64 times 10 to the negative 2 equals K times 0.0252 to the M times 0.0125 to the N. We divide by equation 1. Equation 1 is 1.41 times 10 to the minus 3 equals K times 0.0126 to the M 0.0125 to the n. Okay, so you divide those two equations. The k's cancel. 0.0125 to the n, they cancel. And so we're left with, if you divide 5.64 times 10 to the negative 2 by 1.41 times 10 to the negative 3, you should get 4. So 4 is equal to 0.0252 over, oh, I'm running out of space. So let me move to the right side of the screen. So that becomes 4 is equal to 0.0252 over 0.0126 raised to the m. So 4 is equal to 2 to the m, and that it follows that m is equal to 2. Next, let's do step 2. So step 2, we need to divide equation 3 by equation 1 so that we can solve for m. So equation 3 is 1.13 times 10 to the negative 1 equals k times 0.0252 to the m times 0.0250 to the m, divided by equation 2. 5.64 times 10 to the negative 2 is equal to k times 0.0252 to the m, 0.0125 to the n. Okay, so k's cancel, 0.0252 to the m cancel. If you divide 1.13 times 10 to the negative 1 by 5.64 times 10 to the negative 2, you're going to get 2. So then 0.0250 over 0.0125 raised to the n. It follows that 2 is equal to 2 to the n, so then n is equal to 1. So then m is equal to 2, n is equal to 1. So now we do step 3. Step 3. We substitute the values of m and n in equation 1 and we solve for k. So equation 1, 1.41 times 10 to the negative 3 equals k times 0.0126 raised to the m, but what is m? It's 2, times 0.0125 raised to the n, and n is equal to 1. So if you solve for k, k should be 7105. So then the rate law is rate is equal to k times concentration of NO raised to the m, which is 2, times concentration of O2 to the n, which is 1. This is part A.